write a function is prime n that takes in an integer n and returns true if n is a prime number and false if n is not a prime number. So by definition, a prime number is a positive integer that is larger than 1 and it is only divisible by 1 and itself. So some examples of prime numbers are here: 2, 3, 5, 7, 11, 13. So here notice that the numbers are only divisible by 1 and itself and it doesn't have any other factors. However, non-prime numbers include 4, 6, 8, 9, 10 and so on. So here 4 is divisible by 2 also, which means that this is not a prime number. 6 is divisible by both 2 and 3, which means it's not a prime number, and so on. So here, the challenge is to write your function in one line of Python code. So do pause this video and take some time to give this a go before taking a look at the answer. So before we can write this function in one line of Python code, we need to first write it in many lines of Python code. So let's quickly do this. So define is prime n, and if n is equals to 1, we simply return false, because 1 by definition is not a prime number. And next, we need to check a bunch of numbers. So for I in range 2, n divided by 2 plus 1. Here I'm just going to print I first. So here I'm going to call this function first, is prime on 12, and if I print this, we'll get the following numbers: 2, 3, 4, 5, 6. So these are the numbers that we need to check whether 12 is divisible by. And here notice that we do not add 7, because 7 is more than half of 12, which means that 12 can never be divisible by 7. So in a way, we can choose to check it, but it will always be false. So we might as well not check it. So next, I'm going to check n modulo I. So if I run this, I'm going to get the remainders when 12 is divided by the different values of I. So here, 12 divided by 2 will give us a remainder of 0. 12 divided by 3 will give us a remainder of 0, and so on. So here, for a number to be a prime number, none of this can be 0, which means that I'm going to put this in a if block. So if n modulo I equals to 0, which means that if n divided by I gives us a remainder of 0, I'm going to return false. And at the end of the for loop, we return true. So let's test this for I in range 1 to 21, and we print I, n is empty space, and if we run this, we are going to get 1 to 20 in one straight line. And next, let's call our function. So if is prime I, and let's run this. And here we are going to get the correct prime numbers: 2, 3, 5, 7, 11, 13, 17, and 19. So now that we have written our function in many lines of Python code, we can start to condense this into one line of Python code. So first things first, we start with the smaller stuff. So there is a for loop here, and there's a possibility that we can convert this into a list comprehension. However, here notice that we have a return false in the middle of our for loop. And this isn't good because we cannot really return false in a list comprehension. So here, we have to check this. So I'm going to cut this and put it in front of my for loop and turn this into a list comprehension. So I'm going to remove all of this first. And I'm going to print my list comprehension. So let's comment this out and let's test this on 12 and 13. So once again, if I run this, I'm going to get true, 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 false, true. And for 13, I'm going to get false, 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 false. So here, I'm going to remove the 0. And if I run this again, I'm going to get the remainders when n is divided by I. So here, we get this 0 when 12 is divided by 2. And we get this 0 when 12 is divided by 3, when 12 is divided by 4, and so on. However, for 13, which is a prime number, notice that none of them are 0. So to check whether a number is a prime number, we simply need to check whether 0 is in this certain list comprehension that is generated. So we return 0 in this thing. So let's remove this. So once again, let's test this on our main code. And if we run this, we will get 4, 6, 8, 9, which is not very correct. So here we have to flip it around. 0 not in our list comprehension. And here we will get the correct numbers: 2, 3, 5, 7, 11, 13, 17, and 19. So next, we have to condense this further into one line of Python code. And here, notice that this is simply a if-else block. So to condense an if-else block into one line of Python code, we can use the ternary operator. So if n is equal to 1, we simply return false. So let's settle that first. So return false if n is equal to 1. And here we have to write a else. And else is simply whatever we have here. So once again, let's run this and check if it still works. 2, 3, 5, 7, 11, 13, 17, 19. So this still works normally. And since this works perfectly, we can actually remove the tab here and put this on the same line. And here we have successfully written our isPrime function in one line of Python code. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.